Hi, students, and welcome to Psychology 213 and Experimental Psychology. So today this is the very first lecture, and then it's not going to be very long, and you will see that there are going to be many of these mini lectures kind of corresponds to all the things that we need to cover. Now, given that this is a 6 week class, we're not going to go into extremely detail about it. I'm just going to give you the gist, and then and hopefully you will be able to catch up the rest with the reading. And now the thing that you want to really care about in this class, if you want to do well, is you have to keep up with the assignments. Okay, and I know this is going to be really intense, especially for the 6 weeks. So I'm going to try to put as little as emphasis on the lectures as possible, so you guys will have more time to complete your tests and also your lab reports. Okay, now in this lecture, we're going to deal about the scientific approach to psychology. Okay, now what are some of the characteristics of science and psychology? Well, so general rule is that we need to kind of apply that the construct is similar to human beings. So which means that when people are experiencing love or experiencing like happiness, it's kind of believed that what you are experiencing as an emotion is the same degree of the emotion that I'm experiencing. So basically, this is kind of similar that everybody has a similar reaction when exposed to similar or the same stimuli. So this, the cynics cannot argue, right? So the goal is really to find laws or the theories that really explain a certain phenomenon. So the differences between law and theory is that the law is more kind of regularly associated things, and the theory is basically like in the general sense that many laws together form a theory. So theory is much more undeniable, if you want to kind of think of it as a term. So in the stricter sense, that it's a set of proportions that serves to define events, describe relationships. Okay, and it can be temporal or it can be spatial, and it could be just something that happened before and then followed by something else. So theory is something that is really the basis of science. Okay, now another thing that's really important when it comes to science and also psychology is that we need to have objective evidence. Okay, now when you kind of think about why objectivity is so important in pursuing science, and it's because that when I am making the observation and when I make the measurement, and versus when you or another person who is making the same kind of measurement, and given that the conditions are the same, the outcome should really be exactly the same, or at least very, very similar to one another. Okay, now, so this is why objectivity is so important, because like if you have three people who are measuring, and they should come up with this exactly the same number with the same conclusion. Okay, now this means that the subjectivity is really a problem, because subjectivity can really have a huge issue when it comes to that my view of something is very different from your view of something, and then what happens is that people cannot agree on a certain phenomena, and that's where problems in science comes. Okay, so this is why it's really important to have objectivity. Now, so given that something should be objective, then scientific research questions should be testable. Okay, so which means that if you are having a research question, so for instance, you are wondering if the amount of caffeine that is being drank can that improve your attention, or if that can make you more hungry, or something like that. Okay, so now you have a research question, and then what you need to do is you need to come up with testable statements. Okay, so now what happens if the if the statement cannot be tested? It's not a scientific speculation. Instead, it's just a wild guess. So let's go back to our example of you are wondering if consumption of caffeine can really increase the attention? Well, you need something that measures attention first. Then you can have a person take this attention test before he consumes caffeine, and then um, take the test again after he consumes caffeine. And then if there are any differences, let's say if you see a huge differences in the attention score, then you can more likely draw the conclusion that this most likely it's because the caffeine that is causing the person's attention score to improve in this case. Okay. Now, in order for ideas to be testable, you need to operationally define it. Okay, so what is the operational definition? Well, it's that specific, observable, testable, concrete way of measuring the concept being studied. Okay, so for instance, you got two movies and you want to see if which movie is funnier. The way that you will measure this on a group of audience would not be something like you ask the audience, do you think was funny? Do you think it was funny? And I mean, you will probably want to have something that is more tangible. So, for instance, having a hidden camera that is right in front of the seat of the movie theater, observing how many times the audience laughed. Okay, so this is a good measurement that is something very specific, very observable, and very testable and concrete way of measuring the concept of being studied. Okay, so now let's go back to the survey. If you just kind of stand outside of the movie theater exit and you ask people, did you think that was funny? Did you think that was funny? Do you think that movie was funny? Well, that kind of answer can be a real issue because people they first of all they're not always honest when they give you the actual answer. Okay, and another thing is that based on their personalities, some people might think that, oh, they would say yes to everything, and some would say no to everything. So this is something that is not specific enough, and it's definitely not observable because you're just asking their opinion on something, and it's definitely not testable, right? Because you're basing the whether the movie is funny or not based on their answer of it. Okay, so you can see that the operational definition is very important when it comes to the ideas being testable. Okay. Now, the postdictions are not scientific. Also, what are postdictions? Well, the postdictions are you are saying that this is the reason after the fact or after the event has already occurred. Okay. So after the fact explanations, which are ad hoc is not scientific. Okay. And because, well, it cannot be proven wrong. And and these are explanations are usually untestable. So for instance, if you have a detective that says, oh, I can understand why this girl decided to become a prostitute. She has such a bad childhood. Well, that's not testable. You cannot go back in time and just make someone have a horrible uh, childhood and see if they become a prostitute or not. So this is something that is not, you cannot prove if this is right or this is wrong. And you can also make the argument that, well, there are plenty of people who have a horrible childhood, but not all of them become a prostitute. So these are the things that the post-dictions are not scientific, okay? You cannot just make an after the fact explanation and trying to say that this is the reason and pinpoint down this is the reason, this is the reason, and because scientific approaches does not make that way, does not work that way. Okay, so in order for something to be scientific, you need to come up with a research question, and then you need to come up with a hypothesis. Okay, hypotheses are basically your expectations is what is going to happen, and that goes directly in line with your research question. So let's go back to our example of when a person is interested in knowing if the consumption of caffeine can really change the attention of a person. So he is going to hypothesize that caffeine consumption is going to increase the attention score that is received. Okay, and then only after you have made this prediction, this hypothesis, then you can go out and test them. So most of the process of the scientific research is that you start with a research question and you come up with a prediction or a hypothesis. This is what you're expecting to see. And then you go out, you set up some clever way to make testable, observable, and specific measurement about your concept, about your phenomenon of interest. And in this examples, is going to be attention. And the means of you getting measuring the attention is the attention score. Okay. 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 Now the next part, the scientists are skeptical. Okay. Now uh, just because a common belief that is obvious is true, it doesn't really mean that they will be true when objectively tested. Okay. So the classic example is a Galileo. Is a lot of people thought that heavier objects fall faster than lighter objects, and we know that this is not true. Okay. And then self-report measures, and this is always a huge problem, and there because there is the social desirability effect, in which that people will always want to give you an answer that is kind of more in line with what is socially acceptable. Okay, and there might be also obedience factors. And so the classic two that deals with these are the Darty and Latney study as well as the Stanley Milgram study, which you will see a YouTube link on. Okay, so just watch that. And then the cause and effect relationship, you also want to kind of think about whether or not if something is really the cause of this changes in the readout or in the dependent variable that you are seeing. Okay, so or is this just a pure correlational relationship? And sometimes it's difficult to tease this out, I must say. Okay, so it's really important to kind of make sure that you are doing some sort of manipulation. This is something we're going to talk about later in the semester. Okay. And the last part you kind of really want to make sure is you want to keep an open mind. Just because something a lot of people believe is true, it doesn't really necessarily mean that this is the case. And so you want to kind of think about Copernicus, which he thought about the heliocentric view, which so many people at the time thought that he was wrong and as a heresy. But then it turned out that he was correct. You know, when you kind of think about Stephen Hawkins, that the black hole emits a uh, at subatomic particles, and you know he was also true. He was also right. So a lot of things, you just because something might seem too crazy, it doesn't necessarily mean that it's not true. Okay, so definitely keep an open mind when you are approaching science, not just in this class, but also in the future. Now, if you don't want to become a scientist, just kind of go with the flow in this class. You don't have to deal with this again until next semester when you are taking advanced experimental. Okay. Now, the very last thing you want to talk about is it's really important to share the findings and being productive in science. So this is why the school, I mean, in academia, it's so important to publish. And so this is why academia really adapt this publish or perish model, in which that it's really important to publish your findings because this will allow others to replicate the study. And this is a process that enhances reliability. We'll talk about it in later lectures. And then, so this way that you, if there are any errors, if there are any biases, it can be spotted and corrected. And then definitely, for this will also attract other scientists to work together. And this is a process called collaboration. So you are not going to be the only person in the world that is interested in this one research question. And now you are going to have your technical expertise while other people are going to have their own technical expertise. So for instance, you are, let's say if you're interested in, let's say, Alzheimer's disease, okay, and your specialty is in genetics. And then, and another person who is interested in Alzheimer's disease, but his or her expertise is in patient care and then really observing the behavior of that. Okay, and then you have another person who is a basic neuroscientist who is also interested in Alzheimer's disease, but he or she is more interested in circuits, neural circuits formation and elimination of that. So you can have three of these people that come together that really share their own expertise and then really contribute and find new angles to tackle this devastating disorder and things like that. So these are all very important aspects when it comes to scientific research. Okay. Now, after this lecture, what I will want you to do is to go on to the discussion board and then actually write something. What do you think that makes a good research in psychology or in science in general? Okay, that will be your homework.